guys, this is Nick, and I just wanted to spend a little bit of time talking about a concept that I introduced this week at Reach as part of our question series, and it was the concept of irreducible complexity. And that's just some big words that basically mean that something is designed in a way that if you take a part away from it, that it will cease to function the way that it's supposed to. And the example that we gave for that was a mousetrap. And we talked about how there's about 5 different parts to this mousetrap that make it function and do what it's supposed to do, which is to bait and catch a mouse. And if you were to take any one of those parts away from it, that it would cease to function as a mousetrap. And so there's lots of examples of this in nature. And we used this concept basically as an argument as one of the big issues with the idea of natural selection, of evolution in the sense of one species becoming a different species. So fish becoming amphibians and reptiles becoming birds. The idea being that evolution kind of has this movement from simple organisms to more complex organisms. The problem is sometimes the systems that make up these organisms can't be reduced at all without ceasing to function. Let me give you guys just a couple examples of irreducible complexity, just so you guys kind of have an idea of what I'm talking about. There's a lot of things about the way that the human eye and the optic nerve and the way it communicates with the brain that are more advanced than any camera that humanity has ever made. And so, and if you take any one of those parts away from the eye, then it ceases to function the way it's supposed to. And just the photoreceptor system of the eye is something that we would have had a great difficulty, next to impossible for that to have evolved. If you get like a cut or whatever, then there's actually 3 distinct stages that take place, 3 distinct things that happen for that wound to stop bleeding. We just don't see simpler examples of this system happening in nature. One final example, you guys, and this is the one that's focused on quite a bit, is bacterial flagellum. And now that's basically just like I don't know if you guys have ever looked in a microscope in science class at single-celled organisms, but some of them have these little hair-like kind of leg paddle things that they use to swim through, disgusting pond water or whatever, or through whatever fluid they find themselves in. And the way the joint that connects these flagellum to the bacteria's single-celled body have all these moving parts. And as you guys can see from this picture, it's almost like something you would see on like a machine or a car or something in the way that it's put together in this rendition. And they estimate that there's about 200 separate proteins that make up this system. And if any of those things are taken away, any parts of this system are taken away, then the system ceases to work and you have a bacteria or a single-celled organism that can't move. And if it can't move, then obviously it can't live. And so this is a very, very simple organism in comparison to an elephant or a person or whatever. And but yet it still has these very complex things going on in it. So these are just a few examples of irreducible complexity in nature, and hopefully you guys, that gives you a little bit more of an idea of just one of the major issues that evolution has in being a good explanation for where life came from on this planet.